Hi class, so we are just going to continue our discussion on design of spread footings. No, we are now in the part wherein we check the adequacy against two-way shear or punching shear. No, so again, don't forget to familiarize yourselves with the previous parts, no, uh, of the discussion, no, or the previous videos that I uploaded, no, bago nyo panoorin tong video na to. Okay? And might as well try to compute, no? Kasi I already prepared the notes, no? Much better if you practice it yourself. Okay? So let's begin, no? Okay? And may I remind you na two-way shear is not applicable on wall footings, no? Kasi nga again, uh, wall footings are punching shear are mostly caused by uh, sm- structures with smaller areas such as uh, columns, no, and walls, no, are relatively long and usually acted on by uniformly distributed loads, kaya hindi natin masasabi na may bearing ay may punching shear na nagaganap, no? Okay? So, let's begin. Okay, so from sample problem 1, no, we let me tell you that two-way shear, no, is also called as punching shear. No, so from your strength of materials, no, punching shear, no, are are shearing type of shear stress that happens to uh, some material, no, by uh, causing the material to have holes, no, so tendency ng isang the tendency of a force to the tendency of a material is that it can have holes, no, upon application of the load, no. So on the case of this footing, no, so uh, it is acted on by a factored load or yung tinatawag natin na PU, yung ginamit natin load kanina, no, or in the previous videos, no, as our design load, no. So our PU, concentrated load PU, is acting on the column, no, and then the load from the column shall be transferred on the footing, no. And as you all know, no, it is it shall be reacted uh, by bearing from our soil, no, which is equal to QU, no. But let's talk about, no, what are the codes, no, what is the code saying about two-way shear, no. So ano ba yung sinasabi ng NSCP code, no, when it comes to two-way shear? Okay, so let me transfer this, no, to our NSCP. Okay. Okay, so from your NSCP, we know that according to section 422.6.1.2, nominal shear stress Shear strength for two-way members without shear reinforcement shall be calculated by Vn is equal to Vc. No? So you have to note the difference between the small n and the Vn. No? So napansin nyo, on one-way shear, we use capital V. No? And now, on two-way shear, we are using smaller v. No? So capital V means shear force, no, either in Newton or in kilonewton. In the case of our codes, no, it is equal to Newton, while the small v here is the stress, shear stress, no. So ang unit dapat niyan is in megapascal or in kilopascal. And in the case of the code again, it should be in megapascal. Okay, no? So dahil hindi natin kailangan lagyan ng stirrup yung footing natin, we don't have to put any shear reinforcement, no? Your Vn, your nominal shear stress, no, should be equal to V sub C, no? Shear should be carried by the concrete alone, no? So according to section 422.6.1.4, two-way shear shall be resisted by a section with a depth D and an assumed critical perimeter B sub O as defined by section 422.6.4. Okay? So V sub C for two-way shear shall be calculated in accordance with 402.6.5. Okay? No? So shall not exceed the limits in section 422.6.6.1. Okay? No? So let's proceed first with 422.6.4. What is your critical perimeter B sub O? Okay? So critical perimeter natin shall be located so that the perimeter B sub O is a minimum but need not closer than D over 2 to A and B. No? So we are going to project distance D over 2 from letter A, edges or corners of columns, concentrated loads and reaction area. Changes in slab or footing thickness such as edges of capitals, strap panels, or shear caps. See 422.6.4.1.1, no? So for square or rectangular columns, concentrated loads, reaction areas, critical section. Okay? So this one again. So ibig sabihin, D over 2 natin, susukatin natin from edges of our columns, no? So mamaya papakita natin yan. Okay, for two-way members. Okay, critical section with Okay, so for 422.6.5 shall be calculated with accordance with section 422.6.5.2. Okay, this is your B sub C. Okay, the V sub C natin, no, is the list of formula A, formula B, and formula C. Okay, so formula A are the ones commonly used, no. Yung pinaka-common na ginagamit. Baka don't confuse yourself, no, kung may makita kayong iba, no, this is also equal to 1/3. Okay? Formula B, no, meron tayong beta here. What is our beta here? No? Beta is the ratio of the long side to short side of the column. No? So ratio of the long side to short side of the column. No? So kapag ang column natin is not if our column is not square, no, we can use this. We ought to use this formula. Okay. At C naman, no, we use alpha if we have alpha S if alpha S is If our column, no, is an interior column, meaning to say it's inside your footing, no, alpha S is equal to 40. No? If it's an edge column, meaning to say one face is on the edge, we use the value of 30. While if it's a corner column, meaning to say two sides of it are on the edge, no, we use the value 20. Okay, for formula C. Okay, no? So we are going to use formula A only on this computation, no? Since our column is square, no? Okay, and might as well you want to check this out, formula C, pero it rarely, only on rare cases, no, na naggo-govern yan. Okay, no? So how are we going to utilize these codes, no, in solving, no, for our minimum depth against two-way shear, no? So let's go back to where we are solving. Okay, so now, no, ngayon sinabi ko na kanina na there's a concentrated load P sub U acting on the column, and then the critical section for two-way shear happens, no, when you on the distance d over 2 from the faces of your column. D over 2, D over 2, D over 2, D over 2. So therefore, no, we can form, no, another square here, no, which is equal to 500 plus D and 500 plus D. Okay? So we have a general formula here. Small v sub u is equal to phi multiplied by v sub n. Ang v sub u natin and v sub n should be in megapascal. Okay? V sub u is equal to phi multiplied by v sub c is equal to 1/3. So 0.33 nakalagay sa NSCP kanina, no? Don't confuse yourself, no? Whatever is it that fits you, no, you use it. Square root of f prime of c lambda. Okay? So ang how are we going to compute for v sub u? No, so v sub u is equal to the load, no, the concentrated load, the concentrated factored load 1.2 times 1,200 plus 1.6 times 1,120 multiplied by 1,000. No, so I multiply this by 1,000 in order to convert it into Newton. Okay, so minus 384.305, that is your QU. I divided it by 1,000 as well to make it megapascal, multiplied by 500 plus d squared. Why? Because it is distributed on an imaginary square, which refers to the critical section of your footing against two-way shear over, no, the critical perimeter, no, usually kasi, no, from your strength of materials, no, shear stress are stress due to uh, the load, no, due to the force, no, on an area parallel to it. No? So dapat ang shear stress nangyayari sa mga area na parallel dun sa force. So ang parallel sa force is the critical perimeter multiplied by the depth. No? So is equal to 4 multiplied by 500 plus d multiplied by d. And it is equal to 0.75. That is your phi, no? So medyo paulit-ulit siya. Shear kasi ang shear ulit to, so 0.75 multiplied by 1/3 times 1. Ang lambda natin is 1 kasi I assume that it is a normal weight concrete. Square root of 27.5. Your D minimum shall be equal to 525.705. So you have your depth against one-way shear, minimum depth against two-way shear. No? So ano ba ang susundin natin dito? No? So might as well we're going to have another set of checking, no? Or might be not, no? Pero we are going to decide on that later, no? Kung ano ang gagamitin nating minimum depth. Okay. So we are going to move on now on our next problem. Okay, so let's look at the sample problem number 2, which is a rectangular footing. No, the concept is just the same as our previous problem. No, although they have different dimensions of the footing. No, pero we know na our column is just a square. No, so from our code, no, our BC is equal to the list of the following: formula A, formula B, and formula C. No, so please ignore, no, the formula B because I made a mistake of using formula B. No, so dahil square lang naman ang column natin, no, the longer and the longer and the shorter dimension are just equal. No? So wala na itong formula B. No? So either I just use formula A and formula C only. If I use formula A, no, 1/3 of lambda multiplied by square root of f prime of C, which is equal to 1/3 1 times square root of 28. No? This is equal to 2 square root of 7 over 3. And this is in megapascal. If I use formula C, no, 1 over 12 multiplied by 2 plus alpha S D over B sub O, no, lambda square root of F prime of C. No, ang alpha natin is equal to 40 because it is an interior column. No, 40 D minimum over 4 times 60 plus 4D minimum times 1 times square root of 28. No? So we either choose formula A or formula C as our V sub C. And our VU, no, it's just the same, no, P sub U, no. So mag-extend tayo ng D over 2 from the faces of our column. No, so VU is equal to 4,176. This is our factor load, the 1.2 dead load plus 1.6 live load, multiplied by 1,000 kilonewton, we convert it into newton, minus 271.88, that is your QU, multiplied by 600 plus D minimum quantity squared, no, times 1 over 1,000. Kasi I converted your 271.88 into megapascal over 4 times 600 plus D minimum, no, that is your B sub O times D minimum. Okay, we equate VU to phi multiplied by V sub C. Okay, so let's proceed. Okay, so if we use formula A as our V sub C, no, okay, we use 4176 minus 0.27188 times 600 plus D minimum squared over 4 times 600 plus D minimum multiplied by D minimum is less than or equal to 2 square root of 7 over 3. Our solved value for D minimum is equal to 497.18 millimeter. Okay? That is if we use formula A. If we use formula C, no, 1 over 12 times 2 plus 40 D minimum over 4 times 600 plus D minimum, no, multiplied by 1 square root of 28 is equal to your VU. Okay, no, so don't forget we multiply all of it by all of this by 0.75. Okay, no? So And if we use the formula C as our V sub C, no, this will become 382.88 millimeter. Okay, so we also found out that formula A mostly governs for two-way shear. Okay, so what are we going to choose? No, we discuss it later. Okay. And that ends our video. But I just realized na I made a mistake, no, on the notes, no. From the notes, nung nagsasolve tayo, I forgot to put the fee, which is equal to 0.75 on our V sub C. No, so pag nilagay natin yung fee na 0.75 on our computed values for V sub C, ang masosolve nating value for D minimum is 597.50. Sa formula C naman, we are able to, if we place 0.75 fee, it's 446.79 millimeters. Although it really doesn't much change anything, no? Okay, and again, if you have any questions, don't hesitate to ask me, no? There my blackboards are the blackboard is open, my social media accounts are also open, no. uh, Also, my email, ganyan. And for more announcements, for more updated videos, please like and subscribe, no, to this channel. Okay, thank you very much, no. See you next video.